Right. Let me move this out of the way. Doink. Okay, so sorry. I went through this whole thing with them already. Sorry for my video being short, but or be going over this real fast. I accidentally didn't start it, but A plus BI numbers, what we trick ourselves is turn them into kind of like coordinates in our mind, real part, comma, imaginary part. Then they graph on this new axis, this new coordinate plane called the complex coordinate plane, where this represents the real part of the A plus BI number or X plus YI number, and this represents the imaginary part. So -2 plus 3i, we just in our mind turn this into this and graph it, just like we do in grade school. All right, just believe me, it's a thing. It's made a thing again about why I numbers and why do we have this electrical engineering. And the ability to graph these numbers and move on from this really opens up a world. When it's just -4i, that means A is 0. That's like 0 minus 4i. And then 5 is 5 plus 0i, so it graph accordingly. And then what I did is I asked the students what that formula is. It's a Pythagorean theorem. We'll need that when we have some tough stuff to do. That's how I find r. And then how I find theta from missing information is inverse tan because of what's given. All right, but then this format is what we have to do. So you guys can look now. Look up here. Okay, got you back. I do want you to know shorthand of this. So what we're going to deal with first is when it's in this format, this is easy. When I turn it into this format, that's going to be simple. That's what I work on first because you don't need me for that. You could have done this in January, right when I taught you trig. And I'll show you what I mean by that. Where you need me is to turn this into this format. All right, that's where you're going to need me. And that's when we'll get into the real good stuff here. And I'm going to make up a fourth example. What you could do is pull out that R. Here is one more thing you're going to need to know, though. This is also the same as writing this in this format. Cis theta. What? Okay, what are mathematicians? Don't say jerks. They're lazy. They're lazy. They're lazy. So instead of having to write cosine theta plus I sine theta, this stands for cosine theta plus I sine theta. That's what that does. It replaces that. Actually, I need that right away. You can see one of your questions, right? On the back page of your notes. It's written in this format. Okay, so here's why you don't need me for this. Right? And I do want you to understand, you cannot write this in A or X comma Y format and R comma theta. They got to match and create each other back and forth. So this first one, don't worry about what I just said there. 330, what kind of angle measure that is that? A 30 or a 60? Come on, how far away is it from 360? 30. What's the sine of a 30, everyone? But what is sine in quadrant 4? Negative. So everyone, you would not need me for this. You could, hey, I could just say, hey, evaluate that and simplify that. And this is what you would do. What's the cosine then of a 30? Not 1/2, but what? And then what's cosine in quadrant 4? Positive. And then you could distribute the 2. So this becomes √3 minus I. So there we go. We turned this polar. This is said to be polar form of an A plus BI. This is rectangular form. This is the regular A plus BI or X plus YI that they showed in the notes there. So again, understand the difference. I'm not writing this like this. You'll get marked wrong from writing it like this. You're now in A plus BI complex mode. We got to write this as a complex number, an A plus a BI number. So it's different than converting X comma Y's to R comma thetas and vice versa. But it's not different. Just your answers are different. They look different. Okay, and then I'll write this out. This is why I had to cover this real quick, and I think I covered it well in our shortened version of I didn't start the video on time, so I had to kind of go quick to keep the attention of fifth hour going. Hey, and it's right behind me on the wall here if you still struggle on this. What's the cosine of 3 pi over 2? 0. What's the sine of 3 pi over 2? -1. So this is 6 times 0 plus, and then I can move that I there, 6, commutative property, and then this is -1. I don't know why I did that. That's 0. This just ends up being -6i. Okay? And then that's how you got to write it. So you would not need me for this. Would not need me at all. And then what's the over 4s? Those are √2 over 2. What's cosine in quadrant 2, though? Positive or negative? Negative. What's sine in quadrant 2? I guess I'll write it √2 over 2i, and then you flip in that 4 there. And that becomes 2 cancels. That leaves that as a 2 √2. 2 cancels again and leaves that as a 2 √2i. So notice the difference. If I pulled up your notes from like P1, it was x comma y to r comma theta. Had nothing to do with a plus bi. All right? And you'll see the ability to do this and change these numbers in these formats. Hey, you did your quizzes, right? Bunch of I number operations. That actually opens up a whole new world of doing I number operations faster. If you found that annoying, that little assignment. Okay, now to the harder part. How do I change an a plus bi number into the other format? Well, first of all, you better understand the other format is not just r comma theta. My whole point of making this up here, it's got to be a cis number. It's got to be a cosine of an angle plus I sine of an angle, that same angle with an r value. So the first thing I tell my students is, you're a fool. You tell your students that? Yeah, because some of them are, because they don't listen to me. You saw a second hour today. I'm going through all the stuff. I turn around and people are just staring at their desk like this. All right, and just looking straight down. I'm like, that's great. I'm glad I'm covering this for you. 4, comma, -4. What quadrant are we in, everyone? You probably don't even need any math for this. You shouldn't, because what is this angle measure then? What kind of angle measure has 4 and 4 for both sides? And then that, it's an isosceles triangle. So what's the reference angle? 45. What's the 45 in quadrant 4? No one's answering. I'm going to throw up. No, okay, I know we saw degrees, but let's go back to radians. 7 pi over. Are you okay? Where's your hat? Oh, no. Okay. All right. Did someone finally tell you to take it off? Or are you the brother? Did you guys switch? I would, if I was a twin, I think I'd switch sometimes. Hey, why don't you take my day and I'll take yours? Just see what happens. I would never notice. I would never know. Okay, anyway, so this is 7 pi over 4. All right, for an angle measure. Hey, and then what's this radius? 4 √2. Okay, then someone's going to be like bamboozled by this. Like, where are they getting these dudes? This is what we had in January. A √2 of 45. If you still don't know that, that's on you. That's your problem. All right, so now how do I write this? It's 4 √2 cosine of the angle measure in question plus 4 √2 I sine of the angle measure. And you really should kind of put that in between the number, the radical, and this before the sine. You don't write it first. 4 √2 sine. Some people write it at the end. It just doesn't look good at the end. I don't like it at the end. And then just understand what happens here. What's the cosine of 7 pi over 4 again? √2 over 2. √2 over, or actually 1 over √2 would be another way of thinking of this. Because 1 over √2 times 4 √2 is 4. Do you see what I mean? And then the sine of 7 pi over 4 is negative. Let's change it to 1 over √2. Times 4 √2 is -4i. So we can see how this format, when I go ahead and evaluate and do a circle and go backwards, it does create a plus bi, 4 minus 4i. That's why I need this format. And then if you want to write it like this, go for it. Cis, this should be allowed. Every book I ever deal with, we write them as cis numbers because we're all lazy. All right, but you better understand, that notation. I'm almost done with the notes. I'm doing these two, and then I'm going to add one more as a calculator question because I already did those ones on the bottom. This is why I did this. A plus BI, what does that mean B is? 0. Or, you just go 0, comma, down 2. All right, and then you're there. So I already know what my angle measure is, and I already know what my R value is. What's my R value? Wait, which way did I go? Oh, yeah, I'm sorry. I was just seeing if they paid attention. 3 people did. The rest were like, uh-huh. I'm just kidding. How many people caught that? Raise your hand. Was that a hand, or this is all you can do is just raise that one little finger? Was that your middle finger, by the way, too? Okay, this was wrong. That was right. Okay, what's that angle measure right there? Pi. I know we're doing degrees now, right? The degrees messed you up. So it's pi, and then what's my radius? How far is that? 2. You want to get nuts? You want to do it right away? Sis pi. If you don't like that, then do 2 cosine pi plus it'd be 2I sine pi. And then just a discount double check. What's cosine of pi? It's right behind me. -1. -1 times 2 is what? Good thing no one's sitting around you. They would have fainted. You stole all the oxygen over there. What's sine of pi? 0 times 2I is 0. So 2, you get -2 if you actually evaluated this. So either answer is okay. And I know I haven't done the Pythagorean theorem. It's because these are reference angle. I mean, I already should recognize 1 root 3. Anyone know the triangle 1 root 3? What's the other side? 2a, a root 3, 2a. You can't forget that. I started with that. -1, negative root 3. Okay, and you got to graph it in your mind at least to know what quadrant you're in so you pick the right angle measure. All right? So you know what quadrant you're in. Root 3 squared is 3. 1 squared is 1. 3 plus 1 is 4. Square root of 4 is 2. You should have already known that that is 2. A root 3, 2a. All right, that's the classic 30, 60, 90 side measures. If you don't know that, you look in the mirror and you find out why that person that you're looking at can't figure this out. Anyway, so R is 2, and then we'll go ahead and be a lazy bum and write sis. What's the angle measure? How are your nails looking over there? Good? 4 pi over 3. How do we know that's a 60? Because 60s are always opposite root 3. So it's a 60 in quadrant 4. Again, if you don't like sis, do 2 cosine 4 pi over 3. Hey, what's cosine of an over 3, by the way, everyone? What's cosine of an over 3? Half. All right, so, but it's negative, right? So -half of 2 is -1. I'm just circling back and making sure that this creates the answer I'm looking for. And then 2I sine 4 pi over 3. That's root 3 over 2 times 2, which is root 3 and negative. So this is negative root 3 over 2 times 2 is negative root 3I. So it works, and I'll accept either answer. Now, you want to get nuts? Let's get nuts. Let's put a letter D up here, and let's incorporate the calculator. What did I do with the calculator? I think I did -2 plus 3i. I think that's what I did. We're doing the same thing. Okay, you're a silly fool if you don't think of this graphically. So -2, comma 3, and then I go back to the origin. All right, so this one I have to find R. Or they call it Z, whatever. You want to call it R, go for it. It's fine. I don't know where they use the letter Z. It's just variable usage. It ain't no thing. 3 squared is 9. -2 squared is 4. I swear to dog, anyone that's writing -4 in that position, you should be kicked out of this class immediately. What's a negative times a negative? I get bums do that all the time, and I don't get that mistake is still happening. All right, it happens a lot in my AB class. So R is root 13. Now, here's why I did this. Is this a unit circle value? 2 and 3 for a tangent value per se, you know, because that's all I have. The root 13, no way. So I got to go to the what? Calculator. I got a calculus? What? Calculator. And I love it when I can't see my pointer, just technology. I'm going to move this over. Got to open, I don't know why I closed the calculator again. Okay, and then I'm going to slide this over. You know, can't see my face anymore because I do miss that. I like my fat face in the middle of the notes just so you can see my expressions. Second quit, clear. Okay, and then what do I have to do to find this angle measure? It's a second tan. So second tan, and then let me move this away for a minute. So yeah, you got a second tan and it's 3 over negative 2. So 3 over negative 2. Hit that, come on now, there we go. Second tan, 3 divided by negative, not minus. Don't make that silly mistake. Enter. What quadrant is that in? What quadrant is negative 0.983? Quadrant what? You guys are killing me. You should know this. We've actually done calculator. That's 4. Your calculator has limitations. So 0.983. And this always kills me when students ask the robotic question. What do I do? Add 2 pi or subtract pi or add... Well, this is 0.983 radians here as well. This is a reference angle. It's given as a negative because this is a negative move going that way. Sorry, my marker's a little too thick there, but you get the point. So what do you do in order to find theta? Pi minus, or really pi plus the negative, you know, the negative number that I have on my, you know, the answer. So I'm going to type on my calculator, which is already set as a negative. So that's why, and that lands me in quadrant 2. So second pi plus answer. So that's pi minus 0.983. To not get that is a problem. I don't understand how we don't understand that. Because that is between 0, I'm sorry, wrong. That is between 1.57, which I've written numerous times in this class, and 3.14. Okay, so unfortunately we don't have an exact answer, so we gotta have those decimals in our minds to understand where that's located. So to write this down, what was the answer? 2.159. 2.159. So the answer is root 13 is, I'm going to forget it again, 2.159. Is that right? Okay, and then that's how we can write it in a shorthand version. So I really wanted to cover this because you really got to focus on what quadrant you're in to get the angle measure. If you don't have that thought process, if you don't graph this, then you are creating your own disaster. Your own disaster. And you look in that mirror and you say to yourself, I have created my own disaster. Only I can change my life. I have